Well, hello there, folks. Hope you're doing well. In this video, we are going to be talking about Chapter 5.3, Factoring Trinomials. So, if you're following along in your textbook, by the way, this chapter begins on page 224. Up until now, we have been we've been factoring binomials, which is what we did last chapter, where we took a binomial and separated it into its different factors, right? Like, what two parts can I multiply together to get my binomial? And we're going to do something similar now with the trinomials. And there's a couple ways to do this. This is probably one of the trickiest things for me to teach, at least I find. I hope to do my best with it with you today. So factoring a trinomial, if we go back to our algebra tile example, if we take our trinomial as a rectangle made of polynomial tiles, or of polynomial tiles, is that what we call them now? Algebra tiles, that's what we call them. With my algebra tiles, my factors are going to be the number of tiles that I would put on the top and the side in order to make that rectangle. Let me show you what I mean. So if we look at the first question here, factor if possible, x squared plus 5x plus 4. So what that means, now I'm going to just switch over to the whiteboard scene here, first of all. So what that means is that I have an x squared. Right, I forgot how finicky this can be. So I have my x squared here. And I also have 5x tiles. And I have 4 1 tiles. And these are all positive. So I have these 5 things. What I need to do is rearrange them so that they make a rectangle that we would be able to throw into our algebra tile page. So here's what I'm going to do. So if I take that one big X squared, those 5 long X's, and those 4 1s, I can arrange them this way. I'm going to go back. I can arrange them. There are my tiles once again. So that I have my X squared tile here, 4 of the X tiles next to it in a vertical position, the last X tile in a horizontal position, and then the 4 1s just like this. Now it's important that when you put it in a rectangle like this, you have these clean lines here. We need to be able to see these lines. So you have to arrange your tiles, and this is pretty tricky. If you're going to do it this way, you need to have your own tiles. You have to make them at home or something. Make them out of construction paper, whatever works for you. You have to make it so that they are arranged with these clean lines, because when we find the factors have to be either an X tile or a 1 tile. So if we drew a rectangle like this, we can then say, okay, so if I go straight up, we're doing the opposite of what we did before. So before we would have these side and top, and we would kind of bring it across. So I have an X that way and an X that way gives me an X squared. A 1 that way and an X that way gives me an X. A 1 that way and an X that way gives me an X, etc., etc., etc. So we're just working our way backwards. So I just go straight up. Oh, that's a 1. That takes up a 1 tile space, so that's a 1. That takes up a 1 tile space, that's a 1. That takes up an X tile space, so that's an X. Chances are this might be difficult for you to use. We will come back to the algebra tiles one more time to help solve a slightly different problem. But if this doesn't make sense to you after watching this video, after looking through the textbook, there is another way. And this is the way that I was taught, and I'm a little more comfortable with this way, if I'm being perfectly honest. So let's go back to our original question. Factor, if possible, x squared plus 5x plus 4. So I'm going to go back to the whiteboard and let's take a look at it. So I'm going to write this. I'm going to write this again. So I'm going to write this is x squared plus 5x plus 4. Okay, there we go. X squared plus 5x plus 4. So when I factor it, first of all, I need to arrange it so that I have my x squared first, then my x's, then my 4's. And I can write this in the form ax squared plus bx plus c. Why am I doing it like this? So that I can say, well, what is a equal to? What is being multiplied by x squared to get me x squared? Well, it's just x squared on its own, but a can't be 0 because 0 times something is 0. It has to be equal to 1. B is equal to 5, and C is equal to 4. To factor this out now, well, let's look at what the solution was again. So going back, I didn't explicitly actually tell you the solution. We have on the top here, I have 1x and 4 1s, and on the side here I have an x and 1 1, which means that my factors were equal to x plus 4 1s times x plus 1 1. So I have a 4 and I have a 1. Well, how does this relate to things? Well, it turns out that these two, the b and the c, the a will affect things, but not yet. So the b and the c tell us information about what the factors will be. So for my trinomial, I find out what my b is and what my c is. And then my factors tell me that b is equal to 2 numbers that add to 5, and C is equal to 2 numbers. I spelled numbers wrong. That multiply to 4. And most importantly, the 2 mystery numbers are the same for both. What this means in practice is that we need to list the factors of our C and see which of them add up to equal our B. Once we find them, we found our answer. Let me show you what I mean. So the 2 mystery numbers are the same for both. So let's just erase this top part here. So we'll start with the factors of C. So I've got my factors of C. Well, C is equal to 4. What are my factors of 4? I have 1 times 4 and 2 times 2. So 1 and 4, 2 and 2, those are my factors. I'll now change that to a comma. 1 and 4 and 2 and 2. So I have 2 options to check out. And I want to see when they are added together, what do I get? And when they are multiplied together, what do I get? Well, when 1 and 4 are added together, I get 5. When they are multiplied together, we already know they get 4. When 2 and 2 are added together, I get 4. And when they are multiplied together, I get 4. We already knew that once again because they are factors of 4. If I look here, though, so 5, 5. Great. 4, 4. Well, we already knew it was going to be 4. What that means is that my 2 mystery numbers are the 2 factors of C of 4 that add up to be my B. So the 2 mystery numbers are the two factors, 1 and 4. And if I look here, 1, 4, well, here's my factored thing, 1, 4. So once I find out, let's call our mystery numbers, I don't know, F and G. So mystery number F and G. Once I find my mystery numbers, I can just turn it into X plus F multiplied by X plus G. And that will factor the equation for me. And if you want to be sure, you can always double check. So I can FOIL this out, my outsides. So if I x plus 4 times x plus 1, x times x is equal to x squared. So we're just going to ignore all this over here. X times 1 is equal to 1x. X times 4 is equal to 4x, and 4 times 1 is equal to 4. So I have x squared plus x plus 4x plus 4, or x squared plus 5x plus 4. There we go. So that's the same, which tells us that our original answer was right. My x plus 4 plus my x plus, or multiplied by my x plus 1 are my factors. Whew. That's, hopefully I haven't totally lost you here. So let's try and go maybe a little faster, not much faster. Just a little bit faster for the next one. So the next one says we have x squared plus 4x is equal to 6. So let's go check this out. So x squared plus 4x plus 6. And I need to factor this. So once again, this is my A, this is my B, and this is my C. So I'm looking for two numbers, two mystery numbers that multiply to make 6, but add to make 4. So factors of 6. I always have 1 and 6. And I have 2 times 3. And those are my only options. I have 1 times 6 and 2 times 3. And that's it. So which of these can I use? Well, I make my little table now. So my multiply column, my adding column, and my line here. We know that these are both going to equal 6 when they're multiplied together. That's why they're factors. We have 1 plus 6 is equal to 7. 2 plus 3 is equal to 5. Well, great. We didn't want 7 or 5. We're looking for 4. There are no factors of 6 that make up 4. So that tells me that at this point in my career, I can't factor it. And that's your answer. I can't do it. There is a way to do it. There is a way to do it, but we don't get into that yet. I'm pretty sure that's next year. So there we go. What we were looking for, if we're getting into it, we're looking for integer answers, and there are no integers that are factors. There are non-integer factors that are possible. So that was the answer to B. The answer to B was, I can't do it. C now, we have x squared minus 29x plus 28, and factor that. So let's factor it out. Let's factor it out once again. So I have x squared. Sorry, I moved that a little too high up. X squared minus 29x plus 28. So my A is still 1. My B here is negative 29. And my C is equal to 28. So I've got to find my factors of 28. My factors of 28 1 and 28, 2 and 14, 4 and 7. And I think that those are my options. Yeah, those are my options. So do the same thing, make my little table, multiply and add together. These all multiply to be 28. Honestly, I don't know what the purpose of this second column is, but hey, there it is. There it is. Now we add them together. Well, 1 times 20, or 1 plus 28 is 29. 2 plus 14 is 16. 4 plus 7 is 11. Well, we're really close. We're really close because we have a 29 here, but we're looking for a negative 29. Now, you say, well, what do we do? What do we do? Well, it turns out that there are another 3 pairs of factors that we haven't had to worry about until this point here. So also negative 1 times negative 28 is equal to positive 28. Negative 2 times negative 14. Negative 4 times negative 7 are also options. These are options that we can choose from because they are still equal to 28 each time. 28, 28, 28. And negative 1 plus negative 28 is equal to negative 29. Well, there we go. We have found our factors. We've found our G and F. Or F and G, I mean. We found what we were looking for. So that tells us that this is the same as x plus our f, which is negative 1, multiplied by x plus our g, which is negative 28. Which I can then simplify. I can bring out this negative sign. This is equal to x minus 1, x minus 28. So if, which is my final answer, if I have myself a number where b is a negative and c is a positive, that tells me that I need to look for my negative factor. So it's going to be a negative times a negative. And a negative times negative is going to give me a positive. And that's what we ended up doing in this case. So if you see this in the future where your b is a negative and your c is a positive, you can skip this first half where you use the positive table. You know it's not going to be positive. It's going to be 2 negatives multiplying each other. D now is actually the opposite. So D, we have x squared plus 3xy minus 18y squared. So this is going to this one's going to be a little trickier, I would say. So I'm going to rewrite it first of all, so you guys can see it, so you don't have to look in 2 places at once. So we have x squared plus 3xy minus 18y squared. And I'm not a big fan of this one, just because they try and do too much at once. They try and make it a little too tricky. So what I am actually going to do is I'm going to rewrite it a little bit. We're going to ignore these y's. So we're just going to have x squared plus 3x minus 18, because this is more where we're at right now. So I have my a is equal to 1 still, my b is equal to 3, and my c is equal to negative 18. Well, if c is equal to negative 18, that means I'm looking for 2 numbers that multiply to be a negative number. And the only way I can have 2 numbers that multiply to be a negative number is by multiplying a positive and a negative. So this time I'm going to have to look for all of my factors of negative 18 by looking at my factors of 18 and then swapping between our positives and our negatives. So factors of negative 18. These are my factors of negative 18. And I'm also going to do my little table, my plus and my x, my multiplying. So I have negative 1 and positive 18. Those will multiply together to be negative 18. I could also do positive 1 and negative 18. Negative 2, positive 9, positive 2, negative 9. Negative 3, positive 6. Positive 3, negative 6. I think that's everything. I think that's everything. They write it a little bit differently in the textbook. Either way, if I've done it correctly, all of my options are going to multiply to be negative 18, which indeed they are. So negative 18, negative 18, negative 18, negative 18, negative 18. However, they are going to add to be different things. So negative 1 plus 18 gives me positive 17. 1 minus 18, or plus negative 18, gives me negative 17. They're just going to be inverse pairs. So negative 2 plus 9 gives me positive 7. Forgot my negative. 2 plus negative 9 gives me negative 7. Negative 3 plus 6 gives me positive 3. 3 plus negative 6 gives me negative 3. I'm looking for a b of positive 3, which is that guy right there, which means that my mystery factors are negative 3 and 6. Therefore, x squared plus 3x minus 18 factors into x minus 3, x, x plus 6. And that is the answer to example number 1.